Hello everybody. Today we will study about sound beam and its different regions and their significance. So let's begin our lecture. Know that as sound travel, the shape or width of the beam changes. At the starting point, the beam width is exactly same as that of a transducer diameter. In the near field, the beam start to gradually narrows progressively, like a funnel, until it reaches its smallest diameter, that is focus. After that, the beam expands or diverge in the far field indefinitely until it attenuates completely. Near field is the region from the transducers to the focus. The focus is located at the end of the near zone. The widest portion of near field is equal to the diameter of the crystal. Beam gradually narrows within the near zone, and at the end of one near zone length, beam narrows to 1/2 the width of the active element. Near zone length, also called focal depth or focal length, is the distance from the surface of transducer to the focus. Near zone length is proportional to the diameter of the crystal squared and to frequency. Focus, also called the focal point, is the location where the beam diameter is narrowest. It marks the end of near zone. For a crystal, the width of the sound beam at the focus is 1/2 the crystal diameter as it leaves the transducer. Or you can say, width of an ultrasound beam as it leaves the transducer is double the width of a sound beam at the focus. Far zone, also called the far field. After the focal point is reached, the beam starts to diverge or spread, called the far zone. The far zone is the region starting at the focus. The beam continues to diverge when the beam is 2 times near zone length from the transducer. The beam is again the same size as transducer diameter at 2 near zone length. In far field, beam diameter is equal to the element diameter at depths more than 2 near zone lengths. The beam is wider than the active element. Focal zone is an arbitrary or imaginary region on either side of the focal point where the beam is mostly narrow, described as the region of best lateral resolution. Reflections arising from the focal zone create images that are more accurate than those from other depths. This is the most important region in diagnostic imaging. Focal zone extends equally in near zone and far zone. Half of the focal zone is located in the near field, and 0.5 is located in the far field. For example, if whole focal zone is 4 centimeters, it is 2 centimeters in near zone and 2 centimeters into far zone.